Okay, so in this video, let us answer the question that is organic chemistry question that came in 2024 GCE, that is science paper 2. Okay, so the questions, I've gotten the question from section B and of course section C. Okay, so let us see the question that came. So this one coming from section B, and it was B9, question B9. And the question reads, the following table shows some of the fractions of hydrocarbons obtained from crude oil. The following table shows some of the fractions of hydrocarbons obtained from crude oil. Now, you know that crude oil contains hundreds of fractions. Okay, just to name a few, we have petroleum, diesel, naphtha, bitumen, natural gases, and all those, or refined gases, are the fractions that are found in crude oil. I'm sure you remember the part on purification of crude oil here. Now, the fractions in the crude oil, they are separated according to their boiling points. So in other words, fractional distillation is the one that is used in separating these. And of course, fractional distillation uses the property of the boiling points. Okay, so this is the table that we have here. I was just trying to explain something so that you can have an idea of where we are coming from and what we are supposed to do. So here we are given the fractions A, B, C, and D, and their boiling point range. So the fraction A, the boiling point range is 20 to 60. Then for, of course, B, the boiling point range is from 6 to 110. C is 110 to 200. And of course, D is 200 to 360. What are the questions? What fraction contain the longest chain? What fraction contain the longest chain? Chain of what? So this question, you can also look at it as what fraction contain the longest chain of carbon? So now, how do you know the one that contain the longest chain of carbon? If you look at the properties of these organic compounds, as the number of carbon increases, also the boiling points or their boiling point increases. So the one with the highest boiling point range, if you are to compare A, B, C, and D, is the one with the longest what? The longest chain. So which fraction here? So the fraction is Z. You can say fraction D. Then give a reason for your answer. Give a reason for your answer. Okay, why do you say fraction D has the longest chain? So due to its highest boiling point or boiling range or boiling point range. That is the reason why you are saying it has the longest chain. So due to its highest boiling point range, so you can say as the number of carbon increases, that is in the organic compound, as the number of carbon increases, their boiling point also increases. Or in other words, you can say increase in number of carbon resulting to the increase in the boiling point. So hence the boiling point range in D, or we are saying boiling point, this one with the boiling point 200 to 360 is the one with the longest chain, because as the number of carbon increases, the boiling point also increases. I hope you've gotten that part. Okay. Then the second question, they are saying decane, which is C10H22, can be cracked to produce hexane, which is this one, C6H14, and other hydrocarbon T. So 2 of the products are produced when decane is cracked. So one of them is the hexane, and of course other one is just named as hydrocarbon T. The first question is that deduce the chemical formula of hydrocarbon or deduce the chemical formula of T. So now, one thing you should know that when a compound is cracked, in this case C10H22, when it is cracked, here we are given that it breaks into hexane plus T. Now, we need to account the number of carbon and hydrogens. So when it is cracked, this one just split into 2, okay? In this case, T and D, this one that we are given, which is hexane. Now, this one has 10 carbon, this one has 6 carbon. So which means the remainder of carbon here is what? C4. So the other one will have carbon 4. Then hydrogen, if we are to subtract 14, you are going to find that it is 8. So this one is hydrocarbon T. That is the molecular formula. How do I know? So these products, if we are to add them in terms of number of carbons and all that, number of carbons, number of hydrogen, should be able to give you this one back. I guess you've gotten that part. So finding the or deducing the chemical formula of T, we just look at what are the carbons that remains if we subtract 6 carbon here, which is 4. If we subtract 14 here, 8 remains. To deduce is just to come up, okay? I think we can look at it in that way. So this is the answer. Then draw the displayed structure formula of T. So displayed structure, you need to show bonds. So how many carbons are they? 4. So 4 carbons. Now what kind of a hydrocarbon is this? Wow. So this one happened to be an alkene. So it should be a double bond between 2 carbon. So I'm going to put the double bond there. Then this is hydrogen. 8 of the hydrogens, please. So hydrogens should be 8. So here only 1. Here, so we have 4 so far. I guess nothing is missing. So this is the structure. 1, 2, 3, 4, 5, 6, 7, 8. This is the structure. Would you expect hydrocarbon T to undergo polymerization? Explain your answer. Now, since we've identified that the hydrocarbon T here is what? A butene. Yes, it undergo polymerization. So would you expect the hydrocarbon T to undergo polymerization? Yes. Explain your answer. Now look at this. We said that is butene and it's an alkene. And alkene, you know that they undergo what we call addition. Addition what? Polymerization. They undergo what we call addition polymerization because alkene is a double bond in what? In alkene molecules or compounds. Let me put alkene molecules can break and leave attachment or room for attachment of more molecules. Okay, so in other words, this one I'm just trying to bring out something so that you can explain your answer very well. Okay, I'm not saying that you're going to write exactly this, but just to give you an idea that what we are dealing with is an alkene. And of course, alkene, you know that the double bond can break between the two molecules or simple units. And of course, when they join, they form what we call an additional polymerization. So would you expect hydrocarbon to undergo polymerization? The answer is yes. Why? Because you can say because hydrocarbon T is an alkene in which the double bond can break, and of course more alkene molecule can attach to it, or more of hydrocarbon T can attach. Okay, I think that is what you can basically explain here. But if you have another way of expressing it, you can go ahead and put that. But what I can say is that they undergo additional polymerization, and you know what really happened in terms of the double bond. Okay, so that was the question on section B. But we had also a question in section C. So here is the question. The following table shows the soil pH measured by different crops of growth, for growth. The following table shows the soil pH measured by different crops for growth. So this is the table. So we have the table where we have crops, and we have the table where we have pH. Now at this particular point, you need to know that pH measures how acidity or alkalinity the substance is. In this case, we are talking of soil. So how alkaline or acidic the soil is. Okay, from the pH range, you know that if you were to look at the pH scale runs from 1 to 14. So here pH of 7 in the middle is neutral. Beyond 7 is alkaline. And of course, as you approach 14 there, the alkalinity increases in terms of strength. Then as you go down here below 7, that is acidic. But of course, as you approach 1 there, the acidity tend to be strong. Okay, so you have strong acids as you approach 1. Okay, so now that is not the case. Here what you are given is that crop pH range. So we have peanut, the pH range of the soil, which means this is the pH range of the crops. Okay, so here we have 5.0 to 6.5. Then for millet, you have 6.0 to 6.5. Then of course you have for sunflower, which is 6.0 to 7.5. We have paprika, which is 7.0 to 8.5. And of course we have mango, which is 5.5 to 6.0. Now we are saying a farmer plants peanut and millet crops. Only the peanut crops grow well. So this farmer planted peanut and millet, and out of this only the peanut grew well. Now the question is that predict the pH of the what? Of the soil. Predict the pH of the soil. Now if peanut grew well, then the pH that you are going to predict should be the pH that favors a peanut, or in which peanut grows well. Now let us go a bit back. So look at this. The pH for peanut is 5 to 6.5. So to predict the pH here, you just simply add 5 plus 6.5. I guess this one is able to give you 11.5. Now if you are to divide this one by 2, what is it going to give you? What is going to give you? It will give you 5. Remainder 1 into 2, so you can have 5. Is it 5.5 or something? What is 11.5 divide? So you are required to use a calculator, please. So let me just punch 11.5 divide a 2. So for me, it's giving me 5.75, which I can approximate to be 5.8. So the pH here, we can predict it to be 5.8. Okay, which other crop is likely to grow well in the same soil? So the soil with a pH of 5.8, which other crops is expected to grow well? So you're going to look at the one that has also the pH of this, or closer to this. Now if you look at this 6 point something and 6 point something, if you add this and you divide, you're not going to get 5 point something, you're going to get 6.25. For this one, you're going to get 6 point something. This one you're going to get above 6. But this one, let us try for mango. If you are to add 5.5 plus 6, so it will give us also 11.5. So if you divide by 2, it will give you 5.8. So the one that is likely to grow well here is mango. Okay, suggest what should be done to the soil by the farmer in order for them to grow paprika. What should be done to the soil? So here we are assuming that the soil that they are talking about is this one. Okay, the one with a pH 5.8. So this is acidic, you know that. So less than 7 is acidic. 6.9 coming down is acidic. So which means this soil that we are dealing with here, where this peanut grows well, it is acidic. Okay, now they are saying what should be done to the soil in order for the farmer to grow what? In order for them to grow paprika. We are going to go back and look at the pH for paprika. So the pH for paprika, if we were to look at the pH, we can say 7 plus 8.5, which is just the same as is this 15.5. Now 15.5, if we were to divide by 2, you're going to find that it's almost 7 point. What is 15 divide 2? So 15.5 divide 2. You're going to find that the pH is approximately 7.75, which is alkaline. Okay, so the pH here is alkaline. So what should be done to the soil by the farmer? So the only way to what the farmer is going to do is to treat the soil with what? With a base. Okay, treat the soil with what? A base. What kind of a base? You can use calcium hydroxide or calcium oxide, calcium hydroxide. So you treat the soil with what? A base to raise its pH. Okay, you know that the base neutralizes the acid. So when you add lime to the field, it is going to neutralize the acid, and as a result raising the what? The pH. Remember the pH target is 7.75. So I think that is what the farmer should do. Okay, as you suggest. So treat the soil with a base, or treat the soil with calcium oxide or calcium hydroxide to raise or to neutralize the acid. Let me not say to raise at this point. To neutralize the acid. Okay, to neutralize the acid. Hence raising the what? The pH of the scale. I think that will be enough. Then of course the big question, ammonium nitrate, which is this one, as you can see, is one compound which is added to the soil by many farmers. Explain what ammonium nitrate is added, or explain why ammonium nitrate is added to the soil. Now before we even answer the question, you know that ammonium nitrate is a fertilizer. Okay, a fertilizer. Now what is the function of the fertilizer? So here we are going to say it is added to the soil to improve soil fertility. To improve soil fertility. Okay, that is the reason why it is added. So to improve soil fertility, as a result, it increases what? Yield of the crops, whatever crops that the farmer has planted, it increases the yield. Okay, so the main reason is to improve soil fertility. Okay, so here is another part, that is C. The diagram below shows part of nylon. The diagram below shows part of nylon, a condensation polymer. So this is part of a nylon. Now, where this question is becoming sweet, or where this exam became, or what made this exam interesting, is that normally the monomer for nylon, you know that we have diamine. Okay, diamine as this, okay, diamine as this. Then also we have dicarboxylic. So dicarboxylic also, we present it like this. So here at the end we have the carboxyl group, and also the other part we have the carboxyl group. So this is what we know usually, but this time around, you know that this middle part here is the number of what? Chain of carbons. Okay, chain of carbon, and of course, yeah, chain of carbon. So this one, you should know that here there are carbons. But this time around, instead we are given the number of carbons. Look at it in the middle. Instead of putting this thing, but this time around it came as this way. Okay, so that is what made it interesting, because it has never been phrased this way, or questions have never been phrased this way. This is the first time, and this is impressive. The first question is that deduce the chemical formula of two monomers of nylon, or in nylon. So like I said, if you know the monomers, that this is the monomer and that one, so to deduce the chemical formula of the monomer, you are just simply going to split this part. So this part, you know that it is this part. Then of course this part, you know that it is that part. Now we are not going to present it in that way. We are going to write the chemical formula. So for the first one, what is there? COO. So COO, that is H, something like this. Then now look at where here it is dash what? How many carbons are here? This 4 multiplies that 4 carbons. So carbon. Then how many hydrogens? 4 multiplied by 2, that is 8. So hydrogen. Why am I writing this? Okay, I wasn't supposed to. We are coming to this question. So this one becomes like that. The way it is, you can just connect it like this. Then of course here you have COOH, something like this. So that is the way it should be. And by the way, maybe to make it should be like this, to show that yeah, kind of something like this, because we don't want to same hydrogen as if it's attached to a carbon here. Okay, or maybe we should have written which one is attached to this part. Okay, so it's a carbon, so we should have written it maybe this way, OO, then H, something like this. I guess it will make sense like this. Then the other one, for the second one, which is this part is N. How many? Let's start with hydrogen. How many hydrogens here at the beginning? 2 hydrogens. So 2, then N dash, what is it attached to? C, 2, then here C2H, 2, then 6 dash, then also N. Okay, so these are the molecular formula of the monomers, molecular. Then here they're saying displayed structure. So now displayed structure, that is when we bring in now. Let us start with the first one here, this one. So that one is like this. Then of course is attached to what? How many carbons? This 4 multiplies everything inside, so 4 carbons. So you can put 4 carbons. Then these 4 carbons are attached to this part. I guess you're following here. Then of course we have hydrogens around it, hydrogens, and also hydrogens there, something like this. Okay, so this is how it should appear. That is for one of the monomer, that is the this part. Then of course, what about the second one? So for a second one, this one, start with the nitrogen. Then of course we have hydrogen, hydrogen. Then of course this one attaches. So how many carbons? 6 carbons. This 6 and that. So 1, 2, 3, let me just 3, 4, 5, 6. Then of course at the end is NH, like this. 1, 2, 3, 4, 5, 6 hydrogens. Hydrogens, hydrogens. Even down here, hydrogens. Remember, carbon should be bonded to 4. Should be bonded to 4 bonds. Okay, so I think that is the way it should be. So this and this are the displayed structure. Then now finally D question. So this section C question was 10 marks. The D question is, fishing nets used to be made from natural polymers. Many nylon nets are made from nylon. I mean many nylon. Fishing nets used to be made from a natural polymer. Many nylon nets. Okay, so it's supposed to be many nets are made from nylon. Suggest one advantage and one disadvantage of using nylon rather than natural fiber to make fishing nets. So in other words, I think there's something missing to the question. We are saying fishing nets used to be made from natural polymer. Many nets now, or many nets are made from nylon, or many nets today are made from nylon. Suggest one advantage and one disadvantage of using nylon rather than what? Natural fiber to make fishing net. I guess you get the question. I might have missed some words here, but I guess you get the question. So what we are simply doing here is to give advantages of nylon as the material that is used to make nets now. Now here is something that you need to understand. We are saying used to be made using natural fibers. So natural fibers, they are biodegradable, which means they can be decomposed by bacteria. And of course, in addition to that, maybe we can also talk of they absorb, because the nets are used for fishing. So they absorb moisture. Okay? So they absorb moisture. Okay? Then also it might not be strong. Okay, the strength might not be strong, and of course not elastic. So those are some of the challenges with natural polymers. Then the opposite for artificial, I mean here nylon, you know that nylon is a condensation polymer which is synthetic. So the opposite is that, so I'm giving one advantage, is that nylon has what? High strength, should I say that? Okay, let me just put has low moisture absorption. Okay, so it doesn't absorb a lot of moisture. Then also we can say nylon is what? Is elastic. Okay, elastic. You see what happens when they catch a lot of fish, so it becomes elastic, and of course preventing maybe from bursting or something. Then we can talk of also strength. It is strong. Nylon is made up of those fibers that are very strong, so we can also put that. But now coming to the disadvantages, so these we can put as advantages. Now when it comes to the disadvantages, we can talk of nylon being non-biodegradable. So we can say it cannot be decomposed. Okay, then what is the other thing? it is not fire resistance. Okay, so nylon, when let's say there's fire, can easily melt. Okay, so it is not fire, it is not, or let me just put, it can be damaged, by fire. So quite a number of disadvantages. I think I've opened the mind, I've opened your mind of what you required to put here. But what I can say is that the question was really interesting. The question was well, or the questions were well phrased. I think this is where people faced challenges. For the first time, chemistry was a bit tricky this time around compared to physics, or because of how questions were phrased. So this is what came in terms of organic chemistry. I'm yet to see the multiple choice questions. Okay, otherwise this is where we can end. I hope you've learned something. So please, if you've learned something, kindly subscribe to my YouTube channel. Get to invite more to subscribe to this channel. Let us build it together so that we can reach out to many. And of course, if you are interested in the online lessons, we offer intensive online lessons. And at the moment, we are doing revision. So we are just going through past papers. If you are interested to join us, you can contact the number +26 0976 4025 and 63. And if you are writing GCE 2025, you can still join us. The classes starts. We are still doing the registration, but the classes starts. The earlier you start, the better, especially if you are writing sciences. So please consider starting early so that you don't disadvantage yourself. Otherwise, see you in the next one.